So for part G, it says using the results for part F, or otherwise determine the three side lengths of the only two right angle triangles for which A, B, capital A and capital B are integers. So this was our result from part F. Well, this was it, and it was related to this triangle. So it's a right angle triangle. One side is A, one side is B, and then the other side is A squared plus B squared. And we show that A is equal to 8 over B minus 4 plus 4. Okay, so for these conditions to hold, for A, B, A, and P to be integers, obviously A has to be an integer and B has to be an integer. And then A squared plus B squared, the square root of that has to be an integer because the perimeter is going to be an integer. And the area has to be an integer. Therefore, at least one of these has to be even because the area is a half AB. So if you do a half, I don't know, if you did a half 3 times 5, that's not an integer. But if you did a half 3 times 6, that would be an integer. So at least one of them has to be even. And we also need the area to equal the perimeter. Okay, so we're going to use this, and we're literally, guys, going to deduce it by going through all the different values. There's only 2 that exist. So we're just going to start at the bottom and work our way up until we find the 2. If you know anything about Pythagorean triples, this is useful. Remember, Pythagorean triple, the most famous one is the 3, 4, 5. If this is 3, 4, and then this is 5, 3 squared plus 4 squared equals 5 squared, the answers we're going to get will give us a Pythagorean triple. Anyway, for, I'm going to let B equal, right, in order for A to be an integer, then B minus 4 has to be divisible by 8. So B has to be either 5 for 8 divided by 1 is an integer, or 6, 8 divided by 2 is an integer, or it could be 8 because 8 divided by 4 is an integer, or it could be 12 because 8 divided by 8 is also an integer. So we're just going to try each of them and we'll stop once we get to 2. So let's first try B equals 5. If B equals 5, A equals 8 plus 4, which is 12. And then A squared plus B squared, which is 5 squared plus 12 squared, sorry, the square root of that is the square root of 144 plus 25, which is 169. Square root of 169 is 13. Do that on your calculator if you need to. But that is a famous Pythagorean triple. 5, 12, 13. 5 squared plus 12 squared equals 13 squared. Then the perimeter is equal to 5 plus 12 plus 13, which is 25, 30. And the area is equal to a half. A is 12, B is 5, and we get a half of 12 is 6 times 5 is 30. Therefore, that's the first. That's the first answers. The three sides are 5, 12, and 13. Therefore, sides are 5, 12, 13. Next one, let B equal, let's go with 6. Because if B is 6, I'm going to have 8 divided by 2 is 4. 4 plus 4 is 8. 6 and 8. Therefore, we have 6 squared plus 8 squared is equal to 64 plus 36 is 100. The square root of 100 is 10. Nice. Another one already. So this is our 6, 8, 10 Pythagorean triple, which you may recall. It's actually double our 3, 4, 5 triangle. The perimeter for this is equal to 6 plus 8 plus 10, which is 24. And the area is a half 6 times 8, which is 48 divided by 2, which is 24. So that's my next one. Therefore, sides are 6, 8, and 10. And these are my two triangles. He says there are only 2 right angle triangles, so I don't have to try the other 2 possible ones. This is it. Done. Fine, I didn't actually know that. I learned something during this question, which is nice. Okay, I didn't realize there was only 2 right angle triangles where this property held. Okay, determine the area and perimeter of these 2 right angle triangles. Well, I've done that. I have done that in part I, but let's just write down the answer here. It's only worth 1 mark. For this one, 30 and 30 and or hang on, let's write area equals perimeter equals 30 for, let's say, triangle 1, and area equals perimeter equals 24 for triangle 2. Okay, that's it, guys. That is part G finished.